If you venture deep into the ancient river valleys of the Appalachian Mountains during the peak of summer, the darkness of night reveals a standard, beautiful nature show. At first, a lone firefly sparks to life in the undergrowth. Then another flashes nearby, creating a scattered, chaotic dance of random golden pinpricks in the dark. But as midnight approaches, the random chaos abruptly stops. An eerie, beautiful shift takes over the entire landscape. Suddenly, with absolute precision, thousands of independent insects decide to blink in absolute, perfect synchronization. In a few rare forests on Earth, the entire landscape flashes on and off at the exact same millisecond, acting as a single, massive biological machine. This isn't an optical illusion or a trick of human perception. It is a profound mystery of evolutionary biology that left early Western explorers utterly bewildered. To understand how this impossible coordination takes place, we must isolate the specific species responsible for the spectacle, Photinus carolinus. While there are over 2,000 firefly species on the planet, only a tiny handful possess the unique biological programming required to sync their lights. To uncover the mechanics of the sync, we have to look closely at the intense evolutionary competition driving their reproduction. For a male firefly, the flashing light is an explicit mating call, a visual signature meant to advertise his presence to the flightless females waiting in the leaves below. In ordinary firefly species, every male flashes completely at random, creating a frantic, uncoordinated visual static across the fields. But inside the dense, crowded canopies of synchronous firefly habitats, this random flashing strategy creates a catastrophic sensory overload. When thousands of males flash simultaneously without order, the visual noise becomes so overwhelming that females can no longer identify the distinct rhythm of their own species. Faced with this blinding wall of noise, the female simply stops responding, bringing the entire reproductive cycle of the colony to a grinding halt. To solve this environmental challenge, the Photinus carolinus males evolved a brilliant collective compromise. They agreed to share the timeline. By blinking in absolute unison, they create massive, clean intervals of light, followed by periods of absolute pitch-black silence. During these precise windows of total silence, the females can easily track individual light signatures and flash back their approval without any interference. This evolutionary math makes perfect sense on paper. But how do thousands of independent brains execute a sync down to the millisecond without a central conductor? To find out, mathematicians and physicists began studying the fireflies through the lens of a concept known as coupled oscillators. An oscillator is anything that resets itself in a rhythmic cycle, like a pendulum, a heart cell, or a firing neuron inside a firefly's brain. Every individual male firefly possesses an internal neural pacemaker, an internal biological clock that naturally charges up and fires an electrical pulse to trigger a flash. Left entirely alone in a dark room, a single firefly will flash at its own unique baseline internal tempo, completely uncoordinated with the rest of the world. But when you cluster thousands of these oscillators together, a powerful mathematical rule takes over. The visual cue becomes a physical command. When a firefly's compound eye detects a flash from a neighbor, it doesn't just look at it. The visual input instantly resets its own neural pacemaker. If a firefly is halfway through its internal charging cycle and sees a flash, its brain instantly skips the delay, forces the pacemaker to max charge, and fires immediately. This instantaneous internal resetting mechanism creates a powerful mathematical feedback loop that rapidly ripples across the entire swarm. Within minutes, The faster flashers pull the slower flashers into alignment, causing the entire population to merge into a single, unified neural network. The sheer scale of this sync allows the light waves to travel across vast distances, moving through the thick forest geometry like a stadium wave. To capture this phenomenon with absolute precision, researchers deploy high-speed digital cameras and light sensors throughout the valleys. The data reveals a startling structure. The fireflies execute a rhythmic burst pattern consisting of 6 sharp flashes followed by exactly 6 seconds of total dark silence. This 6-second blackout is the critical operational window where the entire colony holds its breath, waiting for the ground response. Today, this profound biological mastery is changing how human computer scientists design next-generation technology architectures. Engineers are studying the firefly pacemaker loop to synchronize massive global networks of autonomous drones and decentralized computer systems. By eliminating the need for a central master server, devices can synchronize directly with each other using local visual or radio cues, just like the insects. This ensures that if a central node crashes during a critical mission, the remaining units stay perfectly coordinated without missing a single step. Yet, as human cities expand, this ancient biological wonder is facing a silent, existential threat from our own lighting choices. Artificial light pollution floods the night sky, creating a permanent ambient glare that completely drowns out the faint visual cues the insects rely on to sync. When the sync is broken by city lights, the colony fractures back into chaos, blinding the females and threatening the future of the entire population. The synchronous firefly reminds us that the most magnificent masterpieces of engineering are often the most fragile, deeply dependent on the preservation of natural order. Protect the dark, and you protect the code, allowing nature's most impossible light show to keep pulsing its beautiful, unyielding harmony for generations to come.